Let me show you.
Okay, go ahead, Timothy. Yeah.
Show me the product. Let's show the screen. Can you see my screen now?
Yes, we can.
Oh, okay. Thanks. Thank you very much. So I'm very happy that today I have such opportunity to introduce the Apache DolphinScheduler and 3.1 new features updates. And my name is Timothy. So I'm very happy and very honored to represent our open source community of one of the toppest and hottest projects in China. Yeah, and so the first it's about the agenda. So the four agendas we have. So we have the challenge of the big data workflow orchestration, and also the new features that I want to present, and also some tools comparison with other popular tools in the open source community, and also the final I will introduce some great users that have very long-term relationship with this software and the long-term usage of this software. So at very first, we have four main categories that is the challenge of the workflow orchestration. So the first is the machine learning field that we have that we can how to manage the data pipeline, that because you know that the MLOps, there's an end-to-end process which which include the data collecting, cleaning, and a large amount of data storing, and also the prediction and training. And also we want to find a solution that how to ensure the scaling for production environment. Sometimes we need tons of graphic card machines to do the large scale machine learnings, and also for data streaming and how to engage, have a better engagement with the real-time jobs management, and also we have how to solve the difficulties that integrate the real-time data and the batch data integration. And third category is the access code. That means it's not only to use the graphic UI to create and manage the pipeline. We have to make it something like use the code, use some script that can represent the pipeline, represent the workflows. And finally, about the cloud native. That means how to transfer the DolphinScheduler to the modern deployment automations. Use the cloud native way to do the automation deployment, automation recovery, healthy check, something like that. And also we want to have to take a look to see how to use the cloud native way to use and manage tools itself. Okay. So before we dive into the new features, I want to spend a very short time to speak to tell about the previously 2.x version of the DolphinScheduler. As you know, the 2.x version is also a very successful very successful products that being used for many great users in China. And first, we have a drag and drop to create workflows that we can lower down the technology requirement and let the people with less the coding experience to use that. And also we have a DAG graph runtime management, and also we have an open API to support. That means you can use the API to create a workflow, to run a workflow, and also to stop a workflow, and also to get the workflow information. So better integration with other system in your company. And the next is high reliability. We are decentralized. We have multi-masters, multi-workers. That means that because these DolphinScheduler it's controlled by the zookeeper that uses Zookeeper to do the registration, to do the multiple masters and workers. So that means that is the reason we have a high performance. One of the customers have 1 million plus tasks in production environment, because this tool can easily scale out and scale in a very easy way. And so you can add as much task as you can to support some usage, big data usage or machine learning usage. So it's definitely a high reliability. If one worker down, master down, you can recreate a task we create the workflow in another node. And third one's rich workflow functions that we support. You can pause and resume any sub workflow in one workflow, and also the entire workflow. And also we are native support the projects multi-tenant, and we have a 30+ task type. But this is one of the major benefits that you can find almost I think 90% of the common use big data processing and the machine learning processing in the open community. And so we are now supporting to 2.0, 2.x. We support the cloud native extensions. So about the 3.1 new features, I have four categories that from the machine learning that we introduce some of the integration of third parties, and also we support the real time like FLINK Spark streaming and the data streaming management, and we can use the Python YAML workflow to support. And finally, the Kubernetes support use the operators. We do have the operators can install into the installation, and we can run the Kubernetes tasks. Okay. So about the machine learning orchestration that the machine learning orchestration, its main function is to connect the model construction team with the business, the operation, the maintenance team, and establish standardized model development, and operation. So it can meet different needs. So what do we do is about we solve the problem that raise the efficiency of the machine learning life cycles. You can add some pre-work, the data processing, and the modern training, and also deployment, and finally the quality of machine learning, then retrain, then redeploy. So this is a kind of a very comprehensive but very standard life cycle throughout the machine learning fields. And also we are able to connect the other system because there's a multiple way, the variety of solutions tools you can choose in the open source community, and also in some public cloud providers. So this is very important for some big user scenarios. So from the five category, from data management to the model management, we support the task plugs in, and also so for the task plug in the Jupyter, so you can schedule some data analysis notebook. You can write your own Jupyter notebook and add it to one task, one subtask of the workflows. And for the ML flow is open source tools. You can have a building algorithm or model machine learning and deploying machine learning models. About the OpenML database and DVC is the third party you can download. You can store your data for machine learning, even the model, even the training data. And the SegMaker is one of the best machine learning tools by Amazon AWS. So we can schedule the SegMaker pipeline to connect to the upstreaming big data, set down some downstream tasks. And finally is the Pytorch. Pytorch is a tool by Meta, previous Facebook. So it's very popular machine learning library. So you can do some coding for your own training task, and it's also support the Git basis. Now let's jump into the ML flows that we spent a very easy example that can show how it works. So for the ML flows, you can choose the server, the tracking server. I think the ML flow models, and you can choose the deployment flows and the port, and also you can choose the environment like Conda. Conda is a private, it's a private Python environment, and you can have no interference with others. So you can choose your own Conda environment, and then to do the central model registration. So about the OpenMLDB. OpenMLDB, you could the developer can set the path, set the zookeeper address to fetch the data. What I want to mention is that this place you can input some SQL statement. That means you can do some pre data processing for your training features. Sometimes we have very large database. Some of the features is useless, or maybe it's not useful with some of the requirements. So you can do a very simple SQL statement to narrow down the data and to give the best the feature as possible as we can to provide the database for data for training. And the next one is the Jupyter Notebook, and it's very popular tools for the data engine and also the algorithm developer for data scientists. And for the Jupyter book, first you can prepare our typical Jupyter notebook, and you can see here it's a short example that use the ML flow and the pandas. Use the pandas to do some data works and use the ML flow to do the training jobs. And you can see from the left side, there are 4 parameters like experience name, like the C value, the kernel value, model name. So this means these can be injectable. These parameters can be injectable. So from the right side is the DolphinScheduler. As you can. This is one of the tasks in the DolphinScheduler UI. You can input a name, input the node path of the Jupyter Notebook file name, and also you can set the parameters. So that means if I don't do this scripting for Jupyter book, but I can very easy to use the Jupyter book by some others. If he gives enough parameters, I can run this. And also I want to mention you can rely on the previous job that before or after the Jupyter notebooks. I think the same as the DVC. The DVC is also the same with the MLDB, and you can choose some environment. And also the DVC you can input your Git address to get Git address and the data path of the Git address, and also the version. Also the version to get the data for the training. Okay, for the SecMaker is the tools by the Amazon AWS, and after the config, and then you can running the SecMaker job that SecMaker job to set the JSON parameters. You can see you can set the SecMaker the processing instance type. This is typical EC2 instance type, and also some process instance count. So let's continue to the SecMakers. You can see from the left side is DolphinScheduler UI. We have a separated the task that is represented to the SecMaker in the right side. You can see there's one step, and also the SecMaker have some several sub workflow in the SecMakers. I think this scenario is very typical in some of the largest company in China. I remember that there's one of the biggest real estate company. They're very rich, and they have several AI training tasks, and they provided by several public cloud. They not only use the Amazon SecMaker, they also use the actual which is owned by Microsoft, and also Alibaba Cloud, and also IBM Cloud. And because you don't want to buy lots of graphic card on the on-premise environment, they just connect to different cloud providers. So that means he has to use a centralized tool to call the machine learning, the products or tools, or even the API services by the different public cloud providers. So this is very useful for the company such a large company like that. And also after they finish the training, they can easily cycle that the delete and cycle that resources. That's kind of the money saver. So about the PyTorch, I just mentioned before, the PyTorch is very popular tools in the open source by the Meta, and you can see this is another example. So you can reuse some others the code without use your IDE, without edit the code. You can see first you choose the kernel environment that will separate and have no interference with others, and also you can set up the requirements. That means you can install your own or your preferred the Python library by editing the requirements, and also you can choose the Python version, and on the right side the entry function of the main function, and also the GitHub address. So it's very convenient, and you can put the PyTorch in any place of the workflow. And finally, it's about deployment. The deployment. So we use the ML flow to do the deployments after some the data truths, the parameter setting, and also the tracking server. And you can use the URL to do the data predictions of your own models. Okay, so I have a little summarize for the ML orchestration. So currently we support SegMaker, MLflow, the Jupyter, and the DVC, the PyTorch, but in the future we are going to support something like TensorFlow and also the Kubeflow. I want to have a little comments about Kubeflow. Kubeflow is a cloud native. MLOps by Google. So this is natively multi nodes, multi workers, multi-tasks. So it's a typical cloud native algorithm tools. Yeah. So about the existing features, we just support different language. You can put not only Python, you can put the Shell, the Java, and even some Scala in the existing ones. And also we are project levels. We're a project level. We support the multi-tenancies, and we can run the job and the pipeline on demand and scarce. And also the framework library is independent. They use the separate folders. There's the separate workers, and you can parallelize the pipeline executions. As you can see, you can input some parameters by yourself that according to some Jupyter notebook, and also we can retry the failing task in the workflows and even in the sub workflows. So in the future, we are going to support. We underdeveloped to support the rerun changes, automatic scaling, and to do the schema definition about task input and output, and also the dynamic span of the DAG, and also the ML task that I mentioned. ML task on run on Kubernetes is something like the Kubernetes, the Kubeflow. It can implement such requirements. Okay. So let's jump into the next features about real-time and batch job togethers. That means if you have the FLINK job, a real-time job over 100, it's very difficult to maintain that. But about the DolphinScheduler, we can use some project. We can use the DAG to manage huge real-time jobs. Based on my experience, I have a big data project that can use the DolphinScheduler to implement about 200 FLINK streaming walk for one big data clusters, and it's very easy and very good management, because you can use your project. Different teams have different projects, and one project we can separate the different workflows and DAGs. Okay, So we are solve the data pipeline, the real time, the batch time, the gathers. That means you can continuously running real time job and you running batch job before or after that. And also we have a hard the data qualities. We have a soft data quality controls. Yeah. So you can see the correction between the collaboration between the task and the DAGs. So we can support that. I can tell you examples. There's one commercial tools in China which is developed by some of biggest biggest IT company like Huawei, and he has tools, commercial tools. You have to pay that. So it did not have such function that integrate this real-time data and batch data together. So you have one page. You can you just to create the real-time job, and another web page to create the batch job. There's no connection. There's no such DAG for that tools. Okay. So about the FLINK job, the DolphinScheduler is very professional to support a fully parameterable for FLINK jobs. You can choose the main program, the deployment. You can write your script, choose the FLINK version, tasker, the memory number of slots, and task manager, and also the parallelism, the main program parameters. So you can choose a variety of parameters to buy the very easy UI. So this is, I think this is very similar, and even exist compare with some commercial products. It's very professional UIs. And also, I just want to mention, you can see in the right side, we have some SQL statement. That means we are fully support and FLINK SQL functions. This is very useful. As you know, the FLINK is FLINK is one of the biggest contributors company of FLINK is Alibaba, and now Alibaba's they just present our concept that in the futures, no matter the streaming or the batch, they're all using the SQL to do that. So it's very convenient. You can put the SQL here to lower down the development difficulties, and also to have a lot of settings there. You can put lots of settings here to do the FLINK circle streaming and even the batch. I think the same as the Spark job. We have you can choose the Spark version, the main package name, also the memory, the executors, and I think the Spark job we support many. I think it's many years ago. I think DolphinScheduler fully support the Spark. So you can see the Spark SQL. You can also run the Spark SQL to do the Spark batch process. Okay, let's about third category is about the access code. Right now we support the Python. You can use some of the machine learning developer, and also they like to use the Python. So you can write your Python codes here. And also we have YAML. We support YAML. You can see the process name, the schedule, the time, and also you can define the task. I want to mention a little bit more about a little bit more about this page, is because if you just write every pipeline by using the YAML Python, it's very good to initiate the GitOps for the DolphinScheduler task. That I mean that is I mean that if you are a software vendors, you deploy the DolphinScheduler to a variety of customers, and when the deployment, you can use your Git to store these things in your Git repos, and you can fetch from the Git repos. That means you can write some automation scripts. You can recover the whole environment with the contents, with lots of workflows in a flash way. So this is kind of the property management. You can code everything into into the some scripts, some YAML, and then store in the Git, and then deploy to a lot of different kinds of projects. And even if you can parameter things like this, time, scheduler, maybe the tenants, that means you can parameterable, and you can to incorporate with the different kinds of customers' requirements without adding the base repo codes. Yes, very so. I think this kind of little improvement that can bring more confidence to some big companies, some big vendors. Okay, the first category is about Kubernetes integration. I think the left side, I just don't want to mention more, is because it's the typical diagrams of the Dolphin schedule. I won't mention the right side. You can see the right side. We can use the API server to connect to Kubernetes. We can support the FLINK Kubernetes and Smart Kubernetes, and all these two is powered by the Google Cloud. So you can run a lot of jobs if your company have existing Kubernetes clusters, so you can run the jobs with different version. So I think the Smart and FLINK, the benefits that you can support different version in one clusters, and it's resource independent. We have no interference, and also we are multi-tenant, so you can connect as many as the Kubernetes cluster as you can. So it's very easy. So you put the Kubernetes config, you just name the Kubernetes clusters, and also as we test before, we support the EKS of the Amazon AWS, so you can add your class and run the job. And then you can set the namespace quotation for the CPU and memory, some owners that to protect the resources, to set the limitation of the namespace, and then this means you set limitation to dedicated workload. Okay, so I think the final part of the Kubernetes ecology, which is in one of my InfoQ articles. So if your company is already cloud native, implement cloud native solutions, and it's very easy to use to integrate into the GitOps, because we have Helm chart of and also the operator. You can choose Helm chart or operator, whatever you want, to deploy the Dolphin scheduler instance in a very short way. You can see after your deployment, you can fully usage of auto scaling. You can see this is scaling up by the Kubernetes itself. It's very easy. You just change the replica count, and the stateful set job will doing the scale out and scale in. And also, and in the standard Helm chart, we have a health probe that can do the health check by the Kubernetes itself. If the resource, like the pods, is not healthy, it can restart the pods or even protect the pods. So it's a live this probe and read this probe. And finally, this can be managed by LinkD. LinkD is I think one of the graduate project in CNCF. You can use the APM, the HTTP matrix, to analyze and monitoring the performance, the API performance of the Dolphin scheduler. So it's native support Kubernetes ecology. Oh, and also I forget to mention about the FluentB can automatically collect all the Dolphin scheduler loggers to the Elasticsearch without any other additional coding. It's just a script, just some config can solve these problems. Okay, so let's say some of the roadmap. So we continuously to improve our software to to build the IDE. You can do live in programs by using the Dolphin scheduler, and we want to add some more machine learning ops operators, real-time tasker, and also to provide more AWS support, and also the API and the YAML as a code. Let's spend very little time about the tools compression that would compare with some of the best workflow orchestration in the open source. I want to mention some of the points. First is the additional high availability requirements that we are native supported actually by using the zookeepers, but the Azkabans rely on the database, and also the Airflow supported also they rely on some database. And even I want to mention too that even DolphinScheduler is crashed. If your database are still there, you can recover. You don't have to do anything. You just deploy some Java programs or maybe the parts, and everything will back to normal. Yeah, this is our test scenario. And also we overload the processing, which I mentioned before, can support 1 million plus for one companies in the production environment. And also we have a variety of ways of the way to create workflows. We can use UI, we can use the code, and some Azkaban they have a UI, but they cannot use UI to drag and drop to create some workflows and even the airflows. So about the quick deployment that I say, you can use Herb to deploy even just in one click. You don't have to change anything to do some sandbox. But Azkaban have complex deployment. It's not officially have some Kubernetes deployment tools, but we are now supporting operators and Helm chart. And also about the data qualities. Yes, we can stop the workflow if the quality rules are broken, and we can resume later. And Azkaban, the Airflow without this kind of convenience tools. About the pause, and I just talked earlier, we can stop even the subflow, but the Airflow cannot. You can only kill the workflow first and then rerun. About the multi-tenancy, these kind of two things don't have multi-tenancies. So we are native project-based, multi-user space, the multi-tenant spaces. About the task types, yeah, we support 80-90% of the big data processing, machine learning processing, as you can see, and even some traditional like share, like API, like some HiveQL and MR tasks. Okay, so I just want this supportable full version is very useful tools. That means if you create a workflow, then add it to a workflow, then do some change requests, then we submit the workflows, we can automatically record the tag, generate a tag. That means we can support the versioning of your workflow task. Okay, so about so this part of finally we talk about the real-time job. Someone will say the Azkaban and Airflow will use some CLI to do the real-time job, but you know, the DolphinScheduler, we have a professional UI that can help you to very easy to running the real-time job and also integrate with some batch time jobs. Okay, so this is final parts of it. For some of the great users, you can see the IBM, the Tens, and Cisco. Cisco have some Kubernetes initiative for the usage for the DolphinScheduler, and also some of the telecom providers, biggest telecom providers, and also the biggest commercial bank in China, and also I heard some company use the DolphinScheduler to do some vendor support to support as many customers as they can. And also we have some big use case like the China Unicom, one of the 3 major and the biggest telecom providers. We meet their business schedule and function needs and the large data volume requirements and make the lower the cost down. About Shein, it's our online e-commercial company in South China, and but their customers are worldwide. So it's so they use some cloud deployments, use some AWS deployments, or use the Kubernetes support the circuit makers. So we decentralize to ensure the stability and easy to data, and also about the least FM. So we have low code IDE to solve the massive big data task by efficiently computing and some useful ML process. And also you can see some others, partners, users throughout China. Okay, so finally, welcome to join us. You can visit our website and raise some PR and have some discussion with the GitHub. You can write email with and also have raise some questions in Slack. And there's some demo videos you can use to YouTube to check. And you can see right now, I think from this year, 2023, so we are stars about above 10K. Is a significant step for the communities. And finally, you can use a very short command line to start up our sandbox for DolphinScheduler standalone server. You can log in, have UI, very easy way if you have the CE installed. So that's all for today. Thanks very much. Back to you, Vijay.
Okay, thanks, Timothy. So I want to go ahead and share my screen. That was a great session on the DolphinScheduler. Yep. Okay, so I'll talk about Apache Druid and see if I can show a quick demo of how these two come together to orchestrate. Can you see my screen? Okay, I'm assuming everybody can see my screen. So I'm going to go ahead and okay, cool.
Yes, it's clear.
Okay, so this is what I'm going to do. I'm going to talk about the landscape of modern analytics, talk about what an architecture looks like for a modern analytic application, how Druid fits in, and finish up with how Druid fits into the ML pipeline, and then show a brief demo. So if you think of the story of analytics, in the 2000s, the whole notion was how can I store and process data at scale? And in the 2010s, so 2000s when you had your HDFS, data lakes, Spark, etc. The 2010s with the cloud data warehouses, the whole focus was on how to decouple compute and storage, because that obviously reduced the cost of doing analytics. But the current focus is on building an analytic application. And what is an analytic application is what we're going to come to. But typically, an analytic application is something that gives you an interactive data experience when you're processing petabytes of data, when you have thousands to hundreds of thousands of queries per second, and you're processing both real-time and historical data. The thing you see on the UI is an analytic application, right? So people are dragging and dropping stuff and seeing responses immediately and essentially having a conversation with the data, which is what the whole idea of an analytic application is. Right? So let's what examples of analytic application, these are all customers using Apache Druid. So if you think of Netflix, what Netflix is doing is analyzing their the data comes from their OTT platform in real time to get insights on what users are doing. What organizations like DBS and Visa are doing is they are using Druid to show analytics on DBS, especially. What they do is they use machine learning pipeline to predict money laundering, and then use Druid for a human analyst to verify whether that's really money laundering or not. And there are a number of customers who deliver analytics to their external customers. Game Analytics is a game development platform, so they give analytics to their game developers to understand what users are doing with the games. So these are some of the use cases that are used, Druid is used in. So broadly, the characteristics in these situations is that you want interactive analytics at any scale. You're looking at high concurrency at best value, and you want insights on both real-time and historical data. This is what you're looking at. Now, what's the problem with interactivity? Problem with interactivity is that because of the volume and cardinality, the rate of ingestion, and also the concurrency, we often see this spinning wheel of death. There is no interactivity. Things take seconds, minutes. Even in the interactive use case, even something like 30 seconds is really infinite, right? You don't want queries to take that long. So you really need things to happen sub-second. And that's what an interactive experience means. Now, with the cloud data warehouses, there is a lot of excitement about separation of compute and storage. But the problem is when you have extremely high concurrencies, your cost really increases a lot when you try to separate compute and storage, and you need a different approach, and that's where Druid comes in. The last thing is, there is often a need to combine streaming and batch data. What does it need? See, if you're looking at what is happening today, that is your real-time streaming data. But if you want to compare and say whether something has happened today, did it happen last week, did it happen the quarter ago, things like that, then you have to combine the streaming data with the data which you already have, and you need to kind of put the results together, and that's what you need to do today to really understand what's going on. So interactive analytics at any scale, high concurrency at the best value, and insights on streaming and batch data. This is what Druid is made for. This is what Druid really does extremely well, right? So it's what the whole story is. Now, if you think of analytics on one side and applications on the other, what are the requirements? So analytics typically have requirement of doing BI reporting, handling complex queries, being able to handle big data, high cardinality data. This is what analytics cases focus on. The application or transactional databases focus on supporting transactions, asset compliance, write optimization, high concurrency, sub-second responses, and so on. Druid sits in the intersection of these two things. It can handle complex queries. It's very powerful with handling big data, extremely high cardinality data, can handle transactional events, but does not have asset compliance, gives you sub-second response under high concurrency loads. This is what an analytic application is, and Druid is the database for building a modern analytic application. Right? This is what we're thinking about. So just to summarize, these are the three requirements you want. Sub-second at any scale, high concurrency at the best value, real-time and historical insights. Why is Druid the best database to do this? Now, there are a number of things which Druid does which is unique. But traditionally, there has been this notion of the shared nothing architecture, where each node does an atomic piece of work and it does not know what the other nodes are doing. The whole thing is put together, right? So Druid does have a shared nothing architecture. But along with this, Druid also separates compute and storage to offer you the easy scalability. But then separating compute and storage completely makes it very difficult to handle concurrencies. Therefore, with Druid, what is being implemented is prefetching the data from the cloud storage into the local disk, and queries are always run on the local disk. Now, this allows for easy scalability because compute is not really attached to data. However, data is prefetched to the compute. Now, any data can come to any compute, so there is no attachment. So it allows for easy scalability and also allows us to handle concurrent queries really well. So when the data is ingested, it is segmented, it is indexed, and is usually stored in a persistent store on the cloud. The segments are prefetched to the compute nodes ready for query. And this way, clusters can grow to thousands of nodes. This is what happens. Right, so Druid gives us three things. It's very flexible because it's got elastic and distributed architecture. It's got shared nothing cluster with separation of compute and storage. It's very efficient because it is the query engine and the storage are optimized together. The query engine and the storage format, the data format, are optimized together because Druid uses an internal format. It does not store data in a standard format. It has its own format. So the query engine and the data format are optimized together, and it is resilient because there is multiple levels of data replication and automatic load balancing going on in Druid. So the data format is very unique. data is placed in what are called segments, and it's a columnar store. Each segment is a file and a columnar store. Streaming data is held in the memory of the node doing the ingestion. You can query it directly from there. And all data is automatically indexed via bitmap indexes and dictionary encoding. And queries take a fan out, fan in approach for massive parallel processing. It's a scatter gather model. That's what happens when the system is queried. So recovery is automatic because you have redundancy at all layers. So when a node goes down, another node comes up. The cluster is not disturbed. Cluster still processes queries and it still responds to queries. The Druid community is quite large, about 16,000 members in the recent numbers, about 400 contributors, about 1,000+ companies actually using Druid. So let's see what is the deal with the data format. So Druid does a few things with the data format. It compresses the data, dictionary encodes and compresses, uses bitmap indexes and also uses secondary indexes. And there is late materialization because filters are first applied and then aggregation is done. So this is what. So here's an example where you have data encoded as bitmap indexes, and then whenever a SQL query comes with a particular where clause becomes a binary operation because you have a bitmap index. This is kind of how this works. Okay, now the newer capability of Druid is what's called the multi-stage query engine. So traditionally, Druid is very useful for doing interactive queries, but there are use cases like reporting use cases or alerting use cases, which require more than just an interactive query. And so this is what led to the creation of what's called the multi-stage query. The current core Druid engine uses this kind of approach where the query comes to a query node and then it is scattered and then the results are gathered and put together. So this is very useful when you have the need for extremely interactive queries, but not so useful when you need reports and alerts. Right? So you need here an ability to shuffle data across nodes and across stages, right? Just like basically you need to create a DAG, and that's what happens. So we create a shuffle mesh and are able to shuffle data across nodes, across stages, and are able to hence handle the kind of queries that actually require a DAG. So this is what Druid does. So that's very brief on Druid. You can go to the druid.apache.org site and look at more stuff. I'll show you some of the other community resources we have. Now, where does Druid fit into your machine learning pipeline? So broadly speaking, with machine learning, what are you trying to do? You're trying to do exploratory data analytics, which means you want to understand how different dimensions contribute in different time periods. You want to understand behavior of metrics at different granularities and correlation among dimensions. You want to monitor the input and output of machine learning models, because if your data has got anomalies, very likely model predictions have anomalies. And you also need data to train your models. These are the three areas where Druid could potentially fit in. With exploratory data analytics, you want to do things like identify the number of rows with null values and drop the null values with training data. This is a filter operation, very fast in Druid. You want to look at row counts for different categorical variables. This is an aggregation, again, very, very fast in Druid. You want to do things like computing mean, standard deviation, and variance for numerical values, because these are very useful when you're doing when you want to get rid of anomalies, skews in your data before training models. These are statistics on petabytes of data, very fast. Sometimes when you're doing training forecasting models, for example, you want to aggregate at different time granularities. This is a very basically a time series query, again, very fast in Druid. And you want to look at time variation of different metrics with different dimensions, right? So how do the metrics change with different dimensions? Because your whole idea in model training is often to remove variables that are highly correlated. So these become time series queries in Druid, again, very fast. So a typical monitoring pipeline looks like this. You have your machine learning inputs coming in. You go ahead and create, you train a model, your model prediction outputs. The general approach is to bring both the input and the model prediction into Kafka, ingest it to Druid in real time, and then compute anomalies in real time. So there are customers who are doing just this because the customer's whole focus is on offering machine learning as a service to their customers. And if there are anomalies in the model, it affects their customers and hence their overall business, and they want to avoid that. Okay, so that a typical anomaly detection kind of sequence. So you typically have a sequence of metrics, and you want to find what is an anomaly. And what is an anomaly is something you need to understand by looking at different time intervals, which means you need to go back in time, look at last week's data, look at previous month's data, and so on. So it's extremely important to be able to do that, and that's what Druid does well. Model training, you need to extract different types of data, train models on different granularities and compare the accuracy. And often, if you're doing things like training a genetic algorithm, you want to extract thousands of data points from your data lake. And that's very difficult to do in the absence of a high-performance engine like Druid. Okay, so before I do this on what's the community resource available, I just quickly set up a demo. And I have a Druid cluster here. This is what's called the Druid console. You can see a bunch of tables here. You can see some ingestions running through. Now, my task here is that I have a S3 bucket. Let me just see, get that properly positioned here. I have an S3 bucket. I have some data here. So this S3 is a local S3 I've set just for this demo. This is, if you don't know, this is Mini.io, which is simulates S3 in your local setup. So you can use this. So I've got a CSV file which I want to ingest into Druid. So use case typically is you have order data coming into S3, and you need to ingest it into Druid and start doing analytics. This is what the use case is. And what I did was I set up a simple workflow here in the DolphinScheduler, very simple workflow with one task, which is essentially a quick curl command, which basically hits the Druid API. So you can see the command here. So I created a thing called ingestion spec in Druid, and I'm passing it to the Druid API using the DolphinScheduler. This is a very normal requirement when you're dealing with Druid, because Druid does not provide the ability to schedule an ingestion. Real-time ingestion is continuously running, but batch ingestion is something that starts and shut down, and you need to be able to start it when you have data to be ingested, so that you have to either run it through some kind of cron job or use a scheduler like DolphinScheduler to do this. That's what I've done here. I can go ahead and run this workflow here real quick. Pick this worker. I could have just time scheduled it, but the purpose of this demo, I'm just going to run it here. And if I go back to my Druid console, you can see this started running this ingestion here. It will take a few seconds to finish up. Typically, it takes about, because it's a small set of data, few thousand rows, it takes a few seconds to finish up. And the idea is that your data comes into S3, you're running it on schedule. Ingesting data into it's done, and then you go in here and actually you can start querying that data. This is my table I ingested here, orders test. You can see order ID, delivery date, and all that. I can start running queries here. I can do typical SQL queries here in Druid, and let's do that real quick here. You can start doing your analytics, right? So this is what brings these two tools together to actually be able to orchestrate workflows, which ingest data into Druid, and from there you can do your analytics. Right. So that's the quick demo I wanted to show of how these two tools come together. Now, Druid, of course, is also an open source tool. So here are some of the resources. There's a community Slack channel. You can go join the Slack channel. The implies, of course, the company that is commercially backing Druid, but Imply offers POC clinics to our open source users. These are not Imply product sessions. This is absolutely Druid POC clinic. So if you are trying out open source Druid, you want help, please do come to that POC clinic. We also offer tech talks about Druid to anybody who is interested in open source Druid, wants to use open source Druid. We can get on and explain what it does, how it does, what's the best place to use it. The number of open source blogs being put together by me and my colleagues, and these are all available for you to consume. I have one on, using Druid with NiFi, Apache NiFi and Apache Kafka to get data from GitHub and do some analysis, GitHub repositories, analyze the stars and things like that. So a very interesting thing here. One on how to do machine learning model training with Druid. I've got you can take a quick look at this here. It's got a Jupyter notebook here. I've got some code here, so you can definitely take a look at it. So I've got all this checked into GitHub, so you can go play with it, use it for your own projects and so on. So this is all offered by our Imply open source team. Yeah, so the Druid Slack channel, you can use this QR code to join and ask questions, try to make use of Druid. So it's pretty much what I had. I'm going to stop sharing. So I think if any questions are there, we can take it. Otherwise, I guess we're done. Yeah, any questions, comments, thoughts, please feel free. Okay, I guess